somewhere in the darkness of our own cosmic neighborhood. A silent, invisible monster is drifting quietly through space. Not far from Earth. Not in another galaxy. But within our own Milky Way. A black hole. Closer than any we've ever known. For the longest time, we believed black holes only existed far away. In the hearts of distant galaxies or at the edges of time itself. But we were wrong. In 2024, astronomers discovered something extraordinary. The closest black hole ever found to Earth. Hidden in plain sight. No light, no glow, no warning. Only its invisible pull, disturbing the stars around it. In this journey, we'll uncover how it was found, why it matters, and what it means for the future of humanity. Before we dive deeper into the story, let us take a moment to understand what a black hole actually is. A black hole is not a hole. It's a place. A place where the pull of gravity is so strong, not even light can escape. Imagine squeezing something the size of the Earth into the size of a marble. That's how dense it is. Black holes are born from death, the violent collapse of massive stars. When a star burns all its fuel, its core collapses under its own gravity. And if the collapse is strong enough, it becomes a black hole. You can't see it. You can't touch it. You can't even photograph it directly. So how do we know it's there? By watching how it affects the world around it. A black hole warps space. It bends time. It distorts the motion of stars. Sometimes, it pulls matter from nearby stars, creating a glowing disk of hot gas. But sometimes, it hides. Completely dark. Silent. Invisible. These are the quiet ones. The most dangerous ones. The ones like the black hole we just discovered. The one closest to us. It didn't start with a bang. No flash in the sky. No strange light. No cosmic alarm. It began with motion. A star just like many others, quietly drifting across the night sky. But something was off. This star wasn't moving the way it should. It was wobbling. As if being tugged by something we couldn't see. Astronomers using the Gaia Space Observatory, operated by the European Space Agency, were the first to notice it. They were mapping the positions and movements of over 1 billion stars, building a detailed 3D model of our galaxy. One star located just 1,500 light-years away in the constellation Ophiuchus caught their attention. It seemed to be orbiting nothing. Something massive, but invisible, was pulling it in a tight circle. Like a ghost companion. The data didn't lie. No visible object. No light. But a gravitational force strong enough to move a star at incredible speeds. Scientists double-checked. Triple-checked. They used other observatories' ground-based telescopes, spectrographs, infrared data. Still nothing visible. But the star's dance was undeniable. Only one explanation made sense. A black hole. And not just any black hole. The closest one ever discovered to Earth. Just 1,500 light-years away. Practically in our cosmic backyard. They named it Gaia BH1. A black hole about 10 times the mass of our Sun, hiding in the shadows, next to a lonely sun-like star, as if playing a quiet, gravitational duet. Gaia BH1 doesn't shine. It doesn't feed on gas. It just exists, silently. And we never would be found it if we weren't watching. Finding something that emits no light, that leaves no trace in the sky. It sounds impossible. But astronomers have a secret weapon. They don't just look at the sky. They measure it. The first clue came from astrometry, the precise tracking of star positions. The Gaia spacecraft, launched by the European Space Agency, has been orbiting Earth, scanning the stars since 2013. It watches how stars move, not just in straight lines, but in tiny wobbles. Imagine a flashlight being dragged by an invisible rope. That's what Gaia saw. A lone star drifting oddly as if circling a partner that wasn't there. But Gaia alone wasn't enough. Scientists turned to another method, spectroscopy. By splitting the star's light into its spectrum like a cosmic fingerprint, they could see how fast it was moving. As the star orbited, its light shifted. Blue shifted when moving toward us. Red shifted when moving away. The pattern was clear. It was orbiting something heavy. Something with mass. But when telescopes looked for it, nothing appeared. No companion star. No brown dwarf. No faint light at all. That ruled out almost every known object. Except one. A black hole. The star's orbital speed, nearly 30 kilometers per second, told scientists the unseen object had to be around 10 solar masses. That matches perfectly with the stellar mass black hole. And yet, it was not consuming matter, like many other black holes we've seen. It wasn't surrounded by an accretion disk. It was dormant. A sleeping giant. One of the most dangerous kinds. Because we can't see them. We can only detect their silence. By the motion of others. It's like watching leaves swirl in the wind. And knowing the wind is there, even if you can't see it. This is the art of modern astronomy. Measuring the unseen. And turning silence into discovery. So why does this discovery matter? It's not just about finding a black hole. It's about finding the type we didn't think existed, so close to home. Gaia BH1 isn't special because it's big. It's special because it's quiet. Most black holes we've found are feeding, devouring gas, lighting up in X-rays. But Gaia BH1 isn't feeding. It's sleeping. And that means, for every feeding black hole we've found, there could be dozens more just like this one, dark, silent, hiding. This single discovery forces astronomers to rethink how many black holes might exist in the Milky Way. Not hundreds, but millions. And if this one is just 1,500 light-years away, in a random direction, how many more are nearby? How many invisible giants are drifting past us, unnoticed? Let us imagine. What if one of these black holes was heading toward us slowly, silently? Would we see it? Would we feel it? Probably not. Not until it was already too close. As it approaches, it would start pulling on the Oort cloud. That icy ring of comets at the edge of the solar system. Comets might be sent crashing inward. Some toward the Sun. Some toward Earth. The outer planets would feel it next. Slight changes in orbit. Tiny deviations. Until one day, the inner solar system begins to shift. Earth's orbit altered. Climate destabilized. All because of an invisible visitor that we never saw coming. It's unlikely, but it's not impossible, that SY discoveries like Gaia BH1 matter. They are not just astronomy. They are planetary defense. Every time we look deeper into the cosmos, we find something we didn't expect. Quieter. Stranger. Closer. Black holes aren't just in distant galaxies. They're here, lurking in our own Milky Way. But if invisible giants like Gaia BH1 exist, what else could be out there? What other cosmic shadows are we still blind to? Rogue planets, dark matter stars, ancient civilizations, long gone. Maybe the universe isn't empty. Maybe it's just quiet. The universe is ancient, and time stretches longer than we can comprehend. Civilizations rise, build wonders, reach for the stars, and then, they vanish. Maybe they were consumed by their own creations. Maybe they reached the limits of what's possible. Or maybe, they're still out there, watching. And we are still at the beginning. A young species, dreaming of forever, floating on a pale blue dot. But one day, we might face the same fate. We, too, might leave behind only silence. Before that day comes, let us keep looking up. Let us keep searching. Let us keep wondering what's out there, in the dark. If you found this journey through the cosmos thought-provoking, consider subscribing to the channel. There are still many stories hidden among the stars, and together, we'll find them.